Then we go from 70 to less than 75, 75 to less than 80. And that should include all my numbers. So I divide them into equal class widths, then I find my count. So this is my class widths. And then we find our count. So it's basically going through our data and kind of tallying them up. From 55 to less than 60, I'm going to go like this. I'm going to go through my data. I'm like, there's 72. 72 falls in this range. Then I have 68. 68 falls in here. 2 74s right back to back. 68, 74, 68, 74, 74, 66. 74, 66, 76 and 70, 66 and 66, 50 and 70. Thanks for your patience. So I tallied them all up. Really, that's the hard part. Now we take this information and we make a graph. So we label and scale our axes. You've got your y, you've got your x. The y-axis, if you want to be safe, the y-axis is always labeled frequency, no matter what you do. Doesn't matter what the question is, your y-axis is your frequency. It's like saying your count for each of those categories. Your x-axis, what are we talking about? This was your guys' heart rate. And then we scale down here. When you do this, I'm really picky. Not pretty picky, I'm really picky. It goes 55, it goes 60, 65, 70, 75, 80. Don't put this 2 and then the less than sign. Don't go 55 to less than 60. Don't go 60 to less than 70. Go 55, 60, 65, 70, 75, 80. Just like that. No, we're not going to start at 0 on these. Oh, if I put, I'm sorry, you mean like putting the break in there for, yeah, that's good. Put your break in there to know that we're starting at 55 and taking out all the ones in between 0 and 55. My count, I have 1, I have 3, I have 7, I have 7, and I have another 3. So at most when I scale this, maybe go up to 8 if you want. So we're at 0, 1, 2, 3, 4, 5, 6, 7, 8. $55 to less than 60, I had 1 in here, so here's my 1. 60 to less than 65, there were 3. $65 to less than 70, we had 7. We had another 7, 70 to 75, less than 75. And 75 to less than 80, we had 3. Check that out. That's our histogram of heart rates. What can we say about that histogram if we describe it? If you describe it, you need to use your socks. What's the shape of that? Look at this. This had 7 in both of those. This had 3 and this one had 3. And then I had this 1 here. It is almost perfectly symmetrical, which is like random because we rarely ever see that. This is almost perfectly symmetrical except for this one here. Okay? I don't know if mine looks off, but if I were to draw a curve over here, it's, except for that one, it's almost nearly symmetrical. If you said it's slightly skewed to the left, I'd accept that too because I see it, but except for that one value, we're almost perfectly symmetrical. Outliers, are there outliers here? No. So we'd say no outliers. We have center. Here's how we find center with these. And you'll see this come up. There's 1 here, there's 3 here, 7 here, 7 here, and 3 here. Center, what would be the center number? How many numbers do I have? I have 21 numbers up there. What's half of 21? 10.5, right? The 11th value is what we're looking for. So I come in here and I'm like, well, where's that value going to fall? Here's 1, 3 more gives me 4. 7 more gives me 11. So that 11th value, I don't know where it is, but it's going to be somewhere in here, between 65 and less than 70, or would be my center in there. And then my spread. Spread talks about the range, the lowest minus the highest. You could look at your numbers here and say, oh, the lowest number was 58, the highest number was 76. If we subtract those two, we get a range of 18. So the heart rate varied by 18 beats per minute. Or sometimes you're just going to see a graph that looks like this. If we look at this and we say, what's the range here? My highest is 80, my lowest is 55. Sometimes you're not going to have that data to look, so if we just look at this x-axis here, when you find range, we're not using the counts. We're just looking at what was the range in heart rates. It went from 80 down to 55. You subtracted there, we get 25, which is a little different than the numbers we actually subtracted. But that's the other way to do it, okay? How about this one? The following table presents the average points scored per game for the 30 NBA teams in the 2009-2010 regular season. Create 2 histograms, each having a different class width. So when we started on that last one, I said 5 because I like to count by 5. Some people said 2, some people said, I don't know, 4. You can count by whatever you want, but here's what I want you to do. For example, one may have class width of 2 and the other a class width of 5. We're going to do 2 histograms, one with class width 2, one with class width 5, and I'll have you guys try those pretty much on your own, but I'll get you started here. So the first thing we do, figure out what's the lowest, what's the highest, and what are we going to count by. Say it again. This is the lowest. Higher than 110? That's my highest. When you do this, you have to have at least 4 categories, 4 bars on your graph. So don't count by like 20 and you only end up with like 3 bars, 3 class widths when we're done. So we go from 92 to 110. The one says use a class width of 2. It's up to you where you start. It's got to be at least lower than this and at least higher than that is what we have to use as like our min and our max. So we include those 2 values. So say we can even go by 92. Start at 92. I go 92 and I just start counting. 2 less than 94. 94. 2 less than 96. I know. If you want to do it on notebook paper and just say, see your notes. It is itty bitty. And then we tally them up. And the reason I'm not rounding these is because it'll, with those decimals, it'll help me see real quick where does 101.7 go. 101.7 is in here. Yeah, did you guys see that 102? 102 can't go in here because this is less than 102, so it has to go in the category below. That's a great question. So this group here is 102 less than 102. So this might be 101.999. But when you get to 102, this is the one that includes 102. It's the category below it, the class below it. You have your histogram. This side again is always our frequency. At most I have 7, so if we again count up to like 8. And my x-axis here is the points scored per game. And what did we do? We didn't start at 0, so I put in a little break. Then we count 92, 94, 96, 98. I guess you guys really are running out of room. Whoa. We're leaning. If we do one with class width 5, what do we say, 92 to 110? If we count by 5s, I might just start by 90. I might go 90 to less than 95. 95 to less than 100. Why are we doing 2? Because I want to show you what happens when you change your class width. The histogram, it's going to look similar, but it's going to look, really in a sense, way different. Okay? So when you do your homework and when Chloe does her homework and you come back the next day and it's like, why did you get this and why did I get this? Really, you're both most likely going to be right. It's just a matter of somebody started at 92 while the next person started at 91 and counted up that way. And it's going to shift information between your bars, and if you change your class width, it's going to maintain, it's like slightly skewed to the right. It's still going to maintain that same form, but your bars are all going to look different. You're going to have different counts in each of those. How I did these on the right, my numbers. My 92, 94, 96. You see it? This one will go quicker. What's that? When you tally those up, I'm copying from my answer key. I tallied those up. I went back through my list and I'm like, well, 101.7 falls in here. And then I did 99.2 falls in here. So the only thing I did is I changed the class width to count by fives, and then I go back and I retally it. You're only ever going to do one when you do your homework and stuff, but I want to show you what's the difference. Why are some people going to get two different graphs? So in this one, I count up to 15. You remake your graph, and we have something that looks like that. So just to make a quick comparison, what's the difference here? Do they look like the same histogram? No, they don't really look at all alike. But what happens when you change those class widths, the information either shrinks down or it spreads it apart. Kind of like when we split stems. You take your stem plot, it's like all bunched up on the row for 30 and 40 and 50. If we split the stems, it breaks it down and we can see a little better how much are in each of those ranges. Yeah, the book or like a test will probably be a little more picky, but yeah. The only thing I precaution you is here I have 5 bars, which is great. Even if you do 4, you're okay. But if you count by like 10 on that one instead, chances are you're going to end up with 3 bars. You at least have to have 4. You at least have to have 4 classes. Let's do this. Your book assignment, that part 2 for 1.2, histograms. Let's work at that. Yeah, ideally we can check it before you go.